Hi students, myself Tulsi Rautala. I am working as a assistant professor in ECE department in Sesi Institute of Technology and Engineering, Tadepalligud. I want to explain the ECE electronic circuit analysis in ECE department subject, ECE subject. In that subject, I'm telling that analysis of transistor using the H parameters. So I'm explaining the analysis of transistor using the H parameters. Analysis of transistor using H parameters. Transistor is a semiconductor device. It will having the three terminals, that is emitter, base and collector. Everybody knows that. What is the main application of the transistor? The transistor is used as a amplifier. Transistor can be used as a amplifier. What do you mean by the amplifier? If the amplifier is a circuit which is used to increase the strength of the weak input AC signal. That means you are giving as a input as a sinusoidal AC signal. AC signal means sinusoidal signal. You are giving the input, that is a weak input signal, giving to the amplifier. What the amplifier does? The amplifier is increasing the strength of the weak input signal. So it will increase the strength of the input signal. So it becomes output as very large. So amplifier is used to increase the input signal strength. So many types of amplifiers are there. Based on the amplifiers are classified based on the configuration, based on the devices, based on the stages, based on the biasing, based on the coupling, based on the bandwidth. So many amplifiers are there. Based on the, for example, based on the configuration, amplifiers are divided or classified based on configuration. How many types of amplifiers are there based on the configuration? CA amplifier, CB amplifier and CC amplifier. So based on the configuration, the amplifier can be classified into three types. CE, that is the common emitter configuration, CB, that is the common base configuration, CC, that is the common collector configuration. So based on the device, the amplifier can be classified into two types. What are they? BJT and FET. The BJT, FET, these are all types of transistor. BJT is a bipolar junction transistor. The FET is a unipolar junction transistor, that is field effect transistor. So the BJT is a current control device. The FET is a voltage control device. Based on the input, the amplifier can be classified into two types. That is small signal amplifier and second one is large signal amplifier. Small signal amplifier. The small signal amplifier means you are giving the input signal as weak. So there is less fluctuations in the output. That is called a small signal amplifier. Examples: voltage amplifier, current amplifier. These are the examples for the small signal amplifier. Large signal amplifiers means you are giving the input as a large. So there is more fluctuations in the output, that is VCE or IC. In that there is more fluctuations. That is called example. That is called large signal amplifier. Example is power amplifier. Like that, the amplifiers are classified based on this configuration, devices, biasing, coupling, etc. Bandwidth. Based on the bandwidth, the amplifier can be classified into narrow bandwidth amplifier, wide bandwidth amplifier. Based on the coupling, the amplifiers are classified into RC coupled amplifier, direct coupled amplifier. Based on the number of stages, the amplifiers classified into single stage, multi-stage amplifiers. Like that, the amplifiers are classified. In that, coming to our topic, analysis of transistor using the H parameter. My question is, why the transistor can be analyzed? Why the transistor can be analyzed? Why? Because take a single CE, general simple CE amplifier. That means I am not taking any resistors in that. I am taking single CE amplifier. This is a CE, this is a emitter, base, collector. CE configuration or CE amplifier. Why it is called as CE? So the emitter terminal is common in between the base terminal input and the collector terminal output. So the common emitter can be taken between the input and output. That is called the CE. So in that we are giving the input and collector side we are getting the output. We are applying the input voltage in between the base and emitter. So the applied input voltage is VBE. It is in between the emitter and base. So the applied input voltage is VBE and we are getting the output. We are getting the output at emitter and collector terminal. So the output is getting the output from emitter to collector. So the output voltage is VCE and the current is, output current is IC. Input current is IB. Okay. In that the transistor is analyzed. Why? Because of this transistor, because of this amplifier only, there is a variations in the IC. So there is a more variations in the IC. That means if VBE changes, that is input voltage in between the emitter and base, VBE is changes, then IC also changes. So VBE affects the IC. So there is a continuously varied in the collector current. Because of that, there is a non-linearity in the transistor. Non-linearity in the transistor means if you want to find out any current gain, voltage gain, any input impedance, that is Ri or Zi, any output admittance, that is Y0 or Z0. In order to find out this, these are difficult. Why? Because if IC is varies, continuously varies, so you are not finding these parameters. These parameters are called as transistor characteristic curve parameters. In order to find out the current gain, voltage gain, input impedance and output admittance, we are analyzing the transistor as a small signal. So how you are analyzing the transistor? By using the two-port network. We are analyzing the transistor by using the two-port network only. So instead of transistor, we are using the two-port network. First you have to find out by using this two-port network, we are finding the H parameters. By using that H parameters, we are finding all these things. Current gain, voltage gain, input impedance, output admittance, all are find out by using the H parameter by using the two-port network only. So instead of transistor, we are using the two-port network. I shall explain it. first two-port network. This is the block diagram of two-port network. So this is the two-port network. The two-port network is nothing but a transistor. Instead of transistor, we are replacing the two-port network. So transistor and two-port network is same. So two-port network, the name itself tells that two ports. What are they? One is input port. This is the input port. And one is output port. This is the output port. Input port having two terminals and output port having two terminals. What are they? Input port having input current II and input voltage Vi, as well as like that output port having output current I0 and output voltage V0. So there are the two-port network is considering two ports. One is input port and one is output port. The input port having the input current and input voltage, and the output port is having output current and output voltage. From that four parameters, four variables, we are taking the two variables as independent variables and other two are dependent variables. So I am considering, I am having totally four variables, that is II input current, Vi input voltage, I0 output current and V0 output voltage. Four variables are there. From that four variables, I am considering two as independent variable and two as dependent variable. So I am considering II, that is input current, and V0 as taken as the input variable. Independent variable. Independent variable. So other two are I0, V0 taken as dependent variable. Dependent variable. Okay. So II V0 is independent, I0 V0 is dependent. So I0 V0 equals to it is a function of independent variable, that is II, V0. So how we have to represent that? How? I0 V0. I0, Vi. I0, Vi equals to, in that we are using the H parameters, that is H11, H12, H21 and H22. It is a function of independent variables. What are they? II, V0. Okay. Why we are using the H parameters? It is a question. We are having so many parameters, that is Z parameters, Y parameters, ABCD parameters, H parameters. Why we are using the transistor can be analyzed by using the H parameters only. For example, if you take the Z parameters means in Z parameters every parameter is represented as a ohms only. So you have to perform the open circuit operation in Z parameters. If you take Y parameters, every parameter can be represented in mhos or Siemens. So you have to perform the short circuit operation in Y parameters. In H parameters, it is the combination of hybrid. It is the combination of Z and Y parameters. So the H parameters is used to perform the operation like open circuit operation as well as closed, that means short circuit operation. That's why we are using the H parameters. Other that what are the advantages of H parameters? H parameters are the real numbers at audio frequencies. It is easy to find out, it is easy to measure, or it is convertible from one configuration to another configuration. It is easily available from the manufacturer supplies. So that's why we are using the H parameter for analyzing the transistor. It will having the more advantages compared to the Z and Y and ABCD parameters. Okay, coming to our topic, first equation. First equation, VI I naught. So how do you analyze that? VI equals to H11 II plus H12 V naught. This is the equation number 1. Then I naught equals to H21 II plus H22 V naught. This is the equation number 2. If you want to find out parameters H11, H12, H21, H22, how the parameters we will get? By applying the open circuit and closed circuit operation. That means open circuit operation means current will be the 0. Short circuit operation means voltage will be the 0. By applying that, we are getting the H parameters. That is, I can rough it. From that, VI equals to H11 II plus H12 V naught. I naught equals to H21 II plus H22 V naught. Apply the open circuit operation from equation 1. From equation 1, applying open circuit operation means, open circuit operation means put II, that is input current, equals to 0. Put it in the equation 1. VI equals to H11 into 0 plus H12 into V naught. So VI equals to H12 V naught. Therefore H12 equals to VI by V naught. That means that gain means that it is the ratio of input, it is the ratio of output voltage by output current. So it is reverse that. So input voltage by output current. So H12 we can represent it as HR. What do you mean by HR? Reverse voltage gain. So H12 can be represented as HR, that is reverse voltage gain. From that equation 1, then you have to apply the short circuit operation. From equation 1, apply short circuit operation. So V naught equals to 0. Put it in the equation 1. Therefore VI equals to H11 II plus 0. That means H11 equals to VI by II. It is in the form of resistance. V equal to IR, R equal to V by I. So it is V by I, that is V suffix I by I suffix I. I suffix I means input. So input voltage by input current. It is nothing but a resistance Ri. It can be represented in the H form. Hybrid parameters, how we have to represent HI. HI is the input resistance. Okay. From equation 2 apply the short circuit and open circuit operation in from equation 2. I naught equals to H21 II plus H22 V naught. Perform the open circuit operation means II equals to 0 means I naught equals to 0 plus H22 into V naught. So, H22 into V naught implies H22 equals to I naught by V naught. That is the output admittance. That is nothing but it is the reciprocal of resistance. Admittance is the reciprocal of resistance. So, I by V, it is called as admittance. So, H22 equal to H naught, that is the output admittance. From the equation 2, you have to apply the short circuit operation for getting the H21. So, from equation 2, apply short circuit operation. So, V naught equals to 0. Then, what you get? What you will get? I naught equals to 0. I naught equals to H21 II plus 0. That means H21 equals to I naught by II. It is in the form of gain. That means what type of gain you will get? Forward gain, forward current gain. So, it can be represented in the H form, that is H suffix F, that is forward current gain. So H11 is the HI, that is input resistance. H12 is the HR, that is reverse voltage gain. H21 is the forward current gain and H22 is the output admittance. So we are represented. So VI equals to, therefore VI equals to HI into II plus HR into V naught. Put it as the equation number 3. I naught equals to HF into II plus H naught into V naught. Put it as the equation number 4. For example, if you have to analyze this transistor, that is you have to analyze means you have to draw the equivalent circuits. You have to put the values HI, HR, HF, H naught in the equation 3 and 4. You will get the particular equation. So, VI equals to, from equation number 3, VI equals to HI means that is the input resistance, that is VI by II. Substitute H11, that is HI, that is VI by II into VII plus H12, I mean HR. What do you mean by HR? VI by V naught. VI by V naught into V naught. This is the equation number 3. Not number 3. Okay. This II is cancelled. V naught is cancelled. VI equals to VI plus VI. not adding Vi equals to 2 Vi. It is in the form of this equation, this total equation in the form of voltage only. So you have to apply the Thevenin's theorem, Thevenin's circuit, Thevenin's equivalent circuit. All equation is in the form of voltage, then you have to apply the Thevenin's circuit or Thevenin's theorem, because all equation in form of voltage only. That's why you are applying Thevenin's circuit for equation number 3. For equation number 3, you have to apply the Thevenin's circuit. Okay. From equation number 4, I naught equals to, this is the equation number 4, I naught equals to HF into II plus H naught into V naught. Substitutes the values HF and H naught values. So I naught equals to, what you mean by HF? This is the forward current gain, that is H21, that is the HF, I naught by II. I naught by II into II plus, what you mean by H naught? H naught is the output admittance, that is I naught by V naught into V naught. So V naught cancel, II cancel. So the equation, the total equation in the form of current only. So you have to apply Norton's circuit or Norton's theorem. Okay. For equation number 3, you have to apply the Thevenin circuit. For equation number 4, you have to apply the Norton circuit. How it is? Thevenin circuit. From equation number 3, Thevenin circuit. Thevenin's circuit. For equation 3. What is this? Vi equals to Hi into II plus Hr into V naught. So this is the Thevenin circuit. This is the Vi, this is the input voltage, Vi into equals to Hi into II. Hi, this is the II current flows, input current II. Hi is nothing but it is the input resistance. So what is this symbol? Hi, this is the resistance, plus Hr into V naught. This is the voltage generated source. So it will be considered as Hr into V naught. This is the Thevenin circuit for equation number 3. Again, you have to draw the equation number, for equation number 4, you have to draw Norton's circuit. So Norton's means first HF into II, this is the current source. HF into II, HF into II, this is the current source. The current flows, that's the output current, I naught will flows this direction. Next, H naught is nothing but a admittance. It is the output admittance. The resistance and admittance symbols are same, but they are reciprocal. But symbols are same. So the H naught will be considered as a resistance symbol only. This is a H naught. Across the H naught, we are taking the output V naught. This is the Norton circuit. I already told that H parameters is the combination of, it is a combination of H and Y and Z parameters. So the H parameters is the combination of Thevenin circuit and Norton circuit. So if you want to get the H parameter, you can combine the both equation 3 and 4, that is Thevenin circuit and Norton circuit. So it is the combination. This is the H parameter model. This is the two-port network H parameters model. So instead of the transistor, we are replacing this circuit. Instead of the transistor, we are replacing this circuit. Actually, this is the RS. This is the voltage source. Okay. This is the transistor. Instead of transistor, we are replacing that two-port network now. Two-port network. Nothing but a transistor. This is the load resistance RL. Across that we are taking the output V0. This is the RL, means the IL flows through it. This is the I0. This is the II, input resistance. In that we are applying VI. This is V0. So instead of these two-port network, we are replacing this circuit. That is the combination of Thevenin's and Norton circuit. So this is the two-port circuit. Before that, we are introducing this resistance RS as well as this voltage source VS. This is the VS. After that, output from the output part, we are introducing the resistance RL. That is the load resistance. In that IL will flows. This is the overall transistor by using the H parameter model. This is the analysis of the transistor by using the H parameter model. In that we are calculating the current gain AI and voltage gain AV, output impedance, that is output impedance, that is Z0, input impedance, that is Zi, we are calculating. This is the overall analysis of transistor using H parameter. Okay. Now we have to find out the, first you have to find out the current gain. Current gain. That is, the gain is denoted by A. So current gain means A suffix I, capital I. The gain is it is the ratio of output current by input current. So output current by input current. AI equals to output current. The current is started from II, that is the input current, and ended with IL, that is the across the from that RL only you have to take the current IL, that is the load current. So it is started from II and ended with IL. So the output is IL and II is the input. So AI equals to output current IL by II. IL by II. What do you mean by IL? IL and I0 are opposite phase. Okay, IL equals to, therefore IL equals to minus I0. So IL substitute minus I0 in IL. So therefore AI equals to minus I0 by II. So minus I0 by II. We know the equations. VI equals to HI into II plus HR into V0. This is the equation number 1. I0 equals to HF into II plus H0 into V0. This is equation number 2. From 2 equation you can observe I0 and II. Where it is I0 II. the coefficients are, where it is from equation number 2. You can observe equation number 2. This is the I naught, this is the I. So you can take the equation number 2. From equation number 2, I naught equals to HF into II plus H naught into V naught. In that I naught II, okay, same, but V naught is there. So from that circuit, what will be the output voltage? The V equal to IR. I means IL, R means RL. Therefore, V naught equals to IL into RL. We all know IL equals to minus I naught. So, substitute V naught in equation number 2. Therefore, I naught equals to HF into II, HF into II plus H naught into V naught means minus I naught into RL. So, plus minus will be taken. Minus H naught into I naught into RL. Therefore, from that I naught plus H naught into I naught into RL equals to HF into II. Common the I naught term. So, I naught common term. 1 plus H naught into RL equals to HF into II. HF into II. Therefore, I naught by II, that is equals to HF by 1 plus H naught into RL. I naught by II means that is the current gain AI. AI equals to, but AI means minus I naught by II. That means minus HF by 1 plus H naught into RL. So, the current gain AI equals to minus HF by 1 plus H naught into RL. Like that, you have to calculate the voltage gain. I will write the AI in this place. AI equals to minus HF by 1 plus H naught into RL. Put it in the box. Okay. Next, output gain. Output voltage gain. AV. The gain will be considered as A. We have to find out the voltage gain. So, A suffix V. That is output voltage by input voltage. Output voltage means this is the V naught. Input voltage means this is the VI. VI is the input voltage. V naught and VI. Consider from equation number 1. V naught means IL into RL, the voltage. V equal to IR, that is IL into RL. Like that, this is the VI. So, it will be taken as the input impedance ZI or RI. In this, we are taking the output impedance, that is Z0 or Y naught. So, in that, V naught equal to IL RL. Like that, so VI equals to II into ZI. Therefore, VI equals to II into ZI or RI. The resistance and impedance are same symbols. So, you can consider RI or ZI. Therefore, IL by II into RL by ZI. IL by II, that is IL, that is the output current. II means the input current. Output current by input current, that is output current gain AI. AI into RL by ZI or AI into RL by RI. Therefore, A suffix V equals to AI into RL by Zi. I can write it. A suffix V equals to Ai into Rl by Zi or Ri. Anything you can write. Next, you have to find the, what you have to find next? Input impedance, that is nothing but a Zi. Third one is input impedance. Input impedance, that is denoted by Z suffix I or R suffix I. Impedance or resistance is nothing but a voltage by current. So, we have taken the input. So, input voltage by input current, Vi by Ii. Vi by Ii. Next, taken the equations like Vi equals to Hi into Ii plus HR into V naught. Next, I naught equals to HF into II plus H naught into V naught. From that, Vi by Ii, where it is from equation it will be a 1, it will be 2. From equation 1, this is the Vi, this is the Ii. So, taking the equation number 1, from equation number 1, Vi equals to Hi into Ii plus HR into V naught. In this, Vi same, Ii same, but V naught is different. So, you have to write the V naught equation. So, we know V naught equals to I into R, that means IL into RL. IL into RL. So, it can be written as IL by II into II into RL. So, II cancel. Then what you have to get it? IL into RL. So, IL by II, it can be written as AI, that is output current gain into II into RL. Substitute in this equation. Therefore, you will get a Vi equals to Hi into Ii plus HR into V naught. In that V naught place, you are put the value AI into II into RL. In that, common the term II. So, Hi plus RL plus H naught. This is the third equation. Next, you have to find out the admittance. Admittance and resistance are reciprocal. So, the resistance is nothing but a voltage by current, and admittance is nothing but a current by voltage. Output admittance, that is output admittance can be denoted as Y naught, that is output current by output voltage. You have to find out the admittance, means the voltage source Vs will be 0. You have to must and shouldly consider Vs equals to 0. That means if Vs equals to 0 means Rs plus Hi into Ii plus HR V naught equals to 0. From this circuit, Vs equals to 0 means Rs plus Hi into Ii plus HR V naught equals to 0. This means from equation 2, we know I naught equals to HF into Ii plus H naught into V naught. We are taking I naught by V naught. So, we are dividing V naught. Dividing V naught. So, I naught by V naught equals to Y naught equals to HF into Ii by V naught plus H naught. So from that Rs plus Hi into Ii equals to minus Hr into V0. Okay, you have to get Ii by V0. Okay, so Ii by V0 equals to Hr minus Hr, not Hr, minus Hr by Rs plus Hi. Substitute in above equation. So I naught by V naught equals to Y naught equals to HF into I by V naught. Put it in that. So minus HR by Rs plus HI plus H naught. Therefore, admittance Y naught equals to H naught minus HF into HR by Rs plus HI. This is the admittance, overall admittance in the transistor by using the H parameter. Okay. Therefore admittance Y naught equals to H naught minus HF HR by Rs plus Hi. Put it in a box. So we are finding the current gain, voltage gain, input impedance and output admittance. In that, if you consider the source resistance Rs, if you consider the source voltage Vs, then what will be the overall voltage gain, what will be the overall current gain? For example, if you consider this part, overall, if you have overall current gain or overall voltage gain, if you want to find out this, take this part only. So this is the Vs, this is the Rs, in across this is the Zi, this is the input impedance Zi. There will be a voltage V1 for example. So overall voltage gain means AVS, that is considering the source resistance Rs. AVS equals to overall voltage gain means output voltage by input voltage. So V0 by Vs. V0 by Vs. It will be taken as V0 by Vi into Vi by Vs. Vi cancel. So what you have to get? V0 by Vs. V0 by Vi, that means this part only. This part V0 to Vi. So it is the voltage gain AV into Vi by Vs. From that equation, what will be the Vi by Vs? Vi equals to Vs into, this is the voltage source, across that there is a resistance. So Vs into Zi by Rs plus Zi. Therefore Vi by Vs equals to Zi by Rs plus Zi. So substitute in that. This value substitute. AVS, overall voltage gain with considering the source voltage, with considering the source resistance Rs. So AV into A suffix V into Zi by Rs plus Zi. This is the overall voltage gain. Like that you have to find out the overall current gain. How you have to find out overall current gain? This is the voltage source. From that you have to take the current source. This is the current generated source Is. This resistance will be in parallel. So this is the Rs. In that II is current. So overall current gain AIS equals to that is IL by IS. This can be taken as IL by II into II by IS. IL by II, that is the output current by input current, that is AI into AI into II by IS. You have to find it in II by IS. That means II equals to IS into RS by RS plus ZI. Therefore, II by IS equals to RS by RS plus ZI. Substitute in that. So, AI into II by IS means RS by RS plus ZI. This is the overall current gain. Overall current gain. Then you have to find out the power gain. Power gain means voltage into current, V into I. P equals to power gain, P suffix A equals to overall voltage gain, A suffix V into overall current gain, A suffix I. We know that voltage gain means AI into RL by ZI. Substitute on that. AI into RL by ZI into AI. So, the power gain equals to AI square into RL by Z.
Click outside anywhere.
ZI. Therefore, overall current gain equals to AI into RS by RS plus ZI. This is the overall voltage gain. 1, 2, this is 3, 4, 5, 6 and power gain equals to AI square into RL by ZI. Total 7 parameters we have to find now. So, analysis of transistor. By analysis of transistor, we have to find out the voltage gain, current gain, input impedance, output admittance, overall voltage gain with considering the source resistance, overall current gain with considering the source resistance, overall power gain. So, in the brief, why you are analyzing the transistor? The transistor can be analyzed to find all these things. Okay, this is the exact model of analyzing the transistor. It can be taken as for if you want to take it is the common emitter, analyzing the CE by using the H parameter. So, in that you are placing the emitter part HIFE, HOE. If you want to find out it is the common base. In order to analyze the transistor in the common base, the transistor has a common base by using the H parameter. Therefore, AI equals to minus HFB by 1 plus H0 B into RL. Like that we are analyzing any transistor. It is the transistor model. You have to analyze like that only you have to analyze the emitter, common collector, common base. Okay, thank you.